Hello students, in additional exercise problem 4.26 of chapter 4, we have a solenoid 60 centimeter long and radius 4 centimeter has 3 layers of windings of 300 turns each. A 2 centimeter long wire of mass 2.5 gram lies inside the solenoid near its center, normal to its axis. Both the wire and the axis of solenoid are in horizontal plane. The wire is connected through two leads parallel to the axis of the solenoid uh, to an external battery which supplies current of 6 ampere in the wire. The question is, what value of current with appropriate sense of circulation in the winding of solenoid can support the weight of wire. So how much current we should pass through the solenoid so that the wire, small wire placed inside the solenoid remains suspended? That is the question. So let us first start with understanding the question. So here we have a solenoid and let this be the axis of solenoid, and then we have a small wire say placed perpendicular to the axis. So let the small wire be like this, and obviously the wire should fall down because of weight mg, but we want it to remain suspended. Look at the question, how much current we should pass so that the wire remains suspended, it can support the weight. Now who can be the weight? Gravity is responsible for weight. Who can be the opposite force to the weight? So I can say that if gravity is acting downward, uh, ILB can be the force balancing the gravity. So if I want the wire to be suspended, NG has to be balanced by ILB. Okay. Now what is M here? Mass of the wire. G is gravitational acceleration. What is I? Current passing through the wire. We have to calculate it. What is L? Length of the wire. Do we know the length of the wire? Yes, we know. The length of the wire is 2 centimeter. And which B we are talking about? B is magnetic field produced by solenoid. And then I can write this as mg is equal to I L mu 0 Li. Now be careful. Two currents we are talking about here. Let us label them as I1 and I2. Which current we want to find out, we should be clear with. I think I made mistake. This I is the current passing through the wire, the black wire shown here, this black wire. Okay, and that is 6 ampere. So I1 is 6 ampere. I1 is 6 ampere and I2 is the current through the solenoid. We don't know that. What is L? Length of the wire 2 centimeter. What is this N? N is the number of turns per unit length, and that we will have to calculate. So you can take N as N by L. Now we have 3 layers of winding of 300 turns each. So 900 turns total you have in 60 centimeter length. Okay, so this will be 3 into 300 by 60 centimeter. Be careful, convert it into meter, and that is how you will get N. Once you have N available, all the other quantities are available. See, mass of the wire is also given, it is 2.5 gram. Okay, G is 9.8 meter per second square. So just one quantity is unknown here, I2. So first step is to calculate N. Once you have N, apply this formula, carry out calculation and find out I2. That is the current You need to pass through the solenoid winding in order to support the 2.5 gram wire. Thank you.